Autonics. Okay, before we proceed, let me introduce our presenter today. Today we have Mr. Shaidan. Okay, for today's session, we have five main objective. Okay, the first one is an introduction to BD series. Okay, and then we go for setup and installation of BD series, method of teaching BD series, connection to software, and the last one is application and simple demo. Okay, before we go into detail, let me share you a video overview of BD series. Okay, without further ado, I'll pass this session to Mr. Shaidan to share his content. Okay, Mr. Shaidan, you may start. Thank you.
Okay, thank you, Miss Lia. Okay, today, thank you for joining our webinar today. So, today I will share about our BD series, which is a laser sensor, laser displacement sensor. Okay, for this session we will have introduction and then installation. After that, function, BD function, and then we introduce a converter and software, and also the application for our BD series. Okay, we start with the first chapter. Is introduction. Okay, actually the BD series is a laser displacement sensor that can measure a thickness, measure width, level difference, disparity, curve, evenness of the target object by detecting the amount of displacement. Okay, the sensor is offer accurate and stable measurement regardless of target color or material. So the sensor head and amplifier unit are detachable for easy maintenance, and you can connect up to X sensor amplifier. Unit can be interconnected with the mutual interference prevention function. Okay. Okay, our units got amplifier unit, a sensor head, and then the accessory, the bracket, and then the fright core, and also the cable. Okay, our BD series, you also can communicate with the PC by using the add displacement software. So the software, you need to have a BD-CRS, which is a communication converter to communicate with the PC. Okay, this explanation about the sensor head of the BD sensor. Okay, you can see the number one is a power indicator, and then number two is the receiver part, and then number three is emitter part, number four is a emission line, and then this one is number five is a laser emission indicator. Okay, and then the near or far indicator. Okay, number seven is a mounting hole, and then number eight is a connector cable. Okay, for the sensor head spec have three model, which is BD030 and BD065 and also BD100. Okay, it depend on the spot diameter. So the unit in the micrometer. Okay, reference distance for the BD030 is 30 mm, and then BD065 is 65 mm, and then BD100 is 100 mm. So maximum measuring range for BD030 is 20 to 40 mm. BD065 is 50 to 80 mm. And then the BD100 is 70 to 130 mm. Okay. And then the light source. The light source for our BDs is a red semiconductor laser. Wavelength is 660 nanometer. And then the method, optical method, is a diffuse reflection. So our laser class is class 1. So for BD030 is a class 1, and BD065 and BD100 is class 2. So the output is around 300 microwatt and 1 milliwatt for the output. Okay, this is explanation about our unit amplifier. Okay, okay, you can see in this is a Autonics BD amplifier. Okay, you can see the indicator is a laser indicator, range measuring range indicator, and calculation indicator is here. And also we have a direction key. You can select the manual the to select the parameter, and then we have a zero and mode setting key, and then this one is a setting value indicator. You have a high, low, RV, and the analog, and also optimization setting key, and also have a alarm key. sorry, alarm indicator, and judgment indicator, which is high, go, and low. Okay, for the cable connection, connector cable, we have three part lah. One is power, output, and the input. So for the power, normally our code is brown and blue. So the power consumption is 10 to 30 VDC, and then the blue is a common ground. And then for the black color is a high judgment, orange is a low judgment, gray is go judgment, and then also green for alarm. You can connect to lighting to light to give a alarm if alarm happen. And then this white is a analog output. You can transmit this reading to HMI to get you can do a scaling from the BD process value. You can transmit to HMI or PC to check the current process value. And then we have a sheet for analog output ground. So also have a input. Input is pink for external input 1, yellow is external input 2, red is external input 3, and purple is external input 4. So for the function for the input is for timing, and for output reset, laser off, zero compensation. You can select recipe bank A, bank B, or off. Okay, for the BDA1, okay, for the BDA1, the display period is 100 millisecond, and then control input is a NPN open collector. So the judgment output voltage from range plus minus 5 volt, 1 to 5 volt, 0 to 5 volt, and for the current 4 to 20 milliamp. Control output is NPN or PMP open collector output. You can select selectable. Okay, this one is a example of the measuring range. Okay, measuring range. You can see here for this model is a 030. So from the sensor head to the target object is a 30 mm. Okay, so this one is a plus area. Okay, and this one is a minus area. So above this area and below this plus area, the sensor will not detect. It will detect error. So make sure your measurement is in this area. Okay. Okay, this one indicate that the maximum range is from here to here. So above and below is not detect. Okay. Okay, this one LED indicator lah. Indication if for the BD030, the rated measurement is from 25 to 35 mm, and BD65 is a 55 to 75, and BD100 is 80 to 120. So from this range, which the indicator will near on, lah. And then in this range, near and far indicator will on. Okay. Oh, this one, all this spec is got inside our manual. You can download it from the website. Okay, for the installation, okay, this one is a indicator lamp. Regarding the installation, when when you adjust the level, let's say the level is uh, far from the object, if near from the object, so the near LED will turn on, and then if far, the green far LED will turn on, like this. So when you get the ideal distance, both of near and far will turn on. Okay, this one caution for installation. So this one is a correct way to install. So your object must like this. Install the emitter and receiver in parallel to the material or color boundary of the object in parallel. You cannot install in vertical. In horizontal, in parallel, you need to install in parallel. So in series with the moving object is uh, not not advisable. Cannot. So for the rotating object, you must install this direction. Okay, okay. This direction is wrong installation. You must install in parallel with the rotating object. Okay. Also for this part, also same. And then the narrow area of concave object. So you make sure the reflex emitter is get back to the sensor lah, not reflect on the wall. So you must make sure you install like this. Okay. This one also same. So okay, this one install in wall. You need to consider the wall effect, the feedback effect from the wall, that the emitter cannot receive the light. Okay. Okay, this one for black object. For black object, the sensitivity will reduce. So if in case you measure the black object, you must reduce your distance. Let's say you install reference is 100 mm, maybe you reduce to 70 mm. Okay, this for connection with the BDA1, the amplifier, and the sensor head, you must follow this arrow. Okay, in the unit got a arrow, so you must refer to the arrow to connect with the amplifier. Okay, make sure the distance between the sensor head is 30 mm. You need to install this noise filter. So this is important lah to get the stable reading of the displacement. Okay, for communicate with the connecting amplifier unit you, mutually, so you need this connector cable. So the first unit will become master, and then the rest is the slave lah. So you can connect up to 8 amplifier. So one master and then 7 is a slave lah. Okay, for caution, do not supply the power when adding the amplifier unit. So you must turn off the supply first, and then you connect you add the units lah. Okay, for the chapter number 3 is a function lah. I will explain the function of our BD series. Okay, we have here is normally 4 parameter. So for parameter 1, you can select the response times. You can do a selection for the teaching mode, 1 point teaching and 2 point teaching. And then for the output, you can select output type, normally open or normally close. NO mean normally open and NC is normally closed. So for PV display, you can select a standard display. Is a standard is a default, and then the factory default is standard, and you can do a scaling also. So for dot display digit, you can change up to 3 decimal point lah, 3 decimal point. Okay, and then for the scaling, you can adjust the scaling from minus 999.999 to 999.999. Okay, so hysteresis also can do adjustment for the setting, and then the analog output, you can do a scaling for the analog output as well, and also have a error output the two type of error, keep fixed or keep a fixed output, set analog range to the maximum value. Okay, for the parameter number 2, it have a calculation function. Okay, so in calculation function have three three selection. Okay, this one is a add function. Okay, it have also subtraction function and the average mode function. So for the gain you can select until 3. Okay, so the default is a 1. For the filter, you can select the average filter or differential filter. Okay, this one average sample setting, and then median setting. Okay, filter got average and median, and also differential filter. And then this one for whole, you can hold the peak value, bottom value, peak to peak value, and then sample, also average, and then the whole timing. So you can select external input over auto trigger or under auto trigger. Okay, auto trigger level, this one auto trigger level, and auto trigger hysteresis timer. So you can select you can do setting for the timer on delay, output delay, and then the off delay, and also the timer value you can set here. Okay, for the parameter number 3 is input selection. There is a input type, so external input 1, external input 2, external input 3 lah. You can select which function you want to do lah. Let's say you want to do uh, timing input for the external input 1. So you just give input to this setting, and this setting to the timer input 1. You will follow what you're setting. Okay, basically the parameter 3 is for input, and then the parameter 4 is setting related to user convenient function. Okay, this one display direction, you can flip the display also. Okay, this one is for bank recipe setting. It have a 4 bank setting, and then save bank mode. Okay, if nothing press on the key of the amplifier, it will turn the light will turn off. This one is a saving mode. And also have a lock mode. Lock mode, you prevent someone to play with the auto zero function. Okay, and then entering the parameter, and also all key except unlock key lah. If you set to the lock, so unauthorized person cannot touch your setting. And also have a initialize. Okay, if something wrong with the sensor, maybe the setting is out of setting, maybe you need to try initialize the unit. Okay, okay, by use a button you can do a zero compensation. Okay, how to do that is you push the zero key for the 1 second. Okay, push the zero key 1 second, you will do the zero function, auto zero function. Okay, auto zero function normally customer use for to initialize to offset the setting, offset setting, to do a reference zero setting. Okay, it also can use by software. By software you can do zero compensation setting. Just click a button run. Okay, and then for the external input, also give signal zero external input for 1 second. Oh, and also by software you can force it by software off to on. Okay, for the judgment output, we have a high, go, and low lah. So this one is the chart of the high, go, and low output lah. Normally the low value we turn on if below this low judgment range lah. And then after reach the go judgment output in the middle, go output will turn on. After that, if you choose the high output, so the high judgment range will turn on lah. This one is setting for the output lah, judgment output. Okay, for the sensitivity compensation setting, you need to press button mode and button up together, and then you can change the value for the high sensitivity compensation. And then if you want to change the low sensitivity compensation, you press button plus and button arrow down together for 2 seconds. If you change, you can change the low sensitivity compensation. Okay, also have adjustment sensitivity compensation. Normally we have a two mode, which is 1 point teaching and 2 point teaching. Okay, for the 1 point teaching, you just press button mode key, and then step number 2 when 1p show, then push auto for 2 seconds. It will auto teaching for the one teaching mode. Okay, for the 2 point teaching, so you first you need to press button mode key, and then 1p show, then push auto for 2 seconds. After that, after teaching 2 seconds, SB show 2p, then push auto key for 2 seconds, and then teaching object for 2 seconds at the set output range. This one normally for level different. Level different, you need to apply this 2 point teaching. Okay. Also have function for the timer in parameter 2. Okay. You can set the output delay. So depend on the setting of the timer. You have on delay is for delay the output turn on. Okay, this one a time delay lah. You can see the arrow here is a time delay. And then the off output you also can set to off delay. Okay, this one is setting time for the off delay. Okay, the output will delay a bit to off. Okay, and then you need to caution it is impossible to use timer and hold function at the same time. Okay, like I said before, the connection for the amplifier is 8 unit maximum. Okay, master one become master. Okay, this is a communication module, which is a BDCRS. So you need this one to communicate with the software. It's called at displacement software. You need this one to communicate. Okay, for the function also have a calculation add calculation. Okay, so this one is to measure the thickness of the object. So you need to place like this, the object in the middle, and then place two sensors facing each other and adjust the object to the center of them, and then you apply the add function. Also have a calculation for subtraction. When measuring level difference, lifting, bending of the object, you can apply the uh, calculation subtraction. Okay, this one is sensor A and sensor B to measure the level difference between A and B. And also have function for calculation average. Okay, when measuring a flatness of the object, evenness of the target object. Let's say you want to know the evenness of this target object. So you can apply this average calculation. So for the average calculation, at least you have a two sensor. So better is more sensor is more good, more better. Okay, for you also have a filter function. So filter number one is a median, and then we have a averaging filter, and also a differential filter. Okay, this one is a sample for averaging. Okay, you can set the range from 1 to 4096 sample lah. Okay, before we apply the average filter, the result is like this lah. And then after apply, the graph will become smooth. Okay, this one for filter median. Set the number of sampling. After sampling and comparing the value, get the certain value in the middle lah. Normally median is for middle value lah. So this one is possible to filtering the noise value. Okay, and then this one normally for differential filter is to use for level difference. Okay, possible to check the sharp level difference. So averaging the filter is not able to use with the differential filter. Okay, okay, the graph is become like this. Also have a gain setting. So in parameter 2 got a gain setting. When low light, large inclined object, so high gain setting value could be lower resolution and not stable by external noise. Okay, so if the object maybe absorb you detect the black color, you need to apply this again to give more power to the sensor to detect to give feedback to the emitter and receiver. Okay, number 9 is a error display lah. Okay, it also have a error display to you to troubleshoot the problem lah. Okay, for the communication side, converter normally use BD-CRS, and then together with the software, Autonics software at displacement. Okay, this one is a BD-C series communication converter. So model BD-CRS. Okay, the power consumption is a 2.3 watt. Communication function support is RS232 and RS485. So communication speed you can select 9600 until 115k bps. So the default is 115k bps, and then it have 4 LED status indicator. So using this function you can do a real time monitoring, and then execute every BD series features and set parameter by external device. Okay, this converter got a terminal for RS485 terminating the switch. So set the RT when the communication is connected to the RS485 communication connection. Okay. Also have a terminal for the RS485 connector. Okay, this one is a RS232 connector, and the side connector to attach to the amplifier, and also have a status indicator, display power, communication input output or error. Then you can refer to status. And then this one is a communication setting switch to set the communication speed, address, priority bit and stop bit. Okay, you can refer to communication setting detail for manual for details. Okay, normally for the connection RS485 got a 2 pin, A and B. Normally A plus, B is minus. Okay. So how to connect to do connection is the BD is uh, in front, okay, attached to the BD amplifier lah. So the unit is up to 32 unit lah. Unit number 1 until 32 unit. If you using the RS485 communication lah. Okay, this one is setting for the communication setting. For number 1 and number 2 is communication speed selection. Okay. Number 3 to number 7 is for address setting. And then 8, 9 is a parity bit setting. And number 10 is a stop bit setting. Okay. Let's say for communication setting, switch 1 and 2, 1 and 2. So if the switch 1 is both 1 and 2 is on, the baud rate is 9600. If switch number 1 off and switch number 2 on, baud rate is 19200. You can refer to this chart, this table. And also the address for the unit lah. So unit number 1, let's say you want to address number 1 is from number 1 to number 1 is switch 3 to 7 all off until unit 32 you need to on. Follow this logic setting. Okay, also for the parity and the stop bit, okay, 8 and 9 you need to follow this table. Okay, you also have a error indicator lah. Error indicator, if the error indicator is on, meaning the connection problem. If this error indicator is turned on, meaning the connection problem. So the solution, check the connection between the converter and amplifier. You need to make sure the connection is okay. And then if flashing, communication problem. Maybe you need to apply the noise between converter and amplifier, noise filter. If this error is off, meaning it working well, working good. Okay, we go to the software. Number 4 chapter is a software. Normally you use add displacement software. So add displacement is a dedicated software for BD series laser displacement sensor. The intuitive graphic user interface allow user to easily set parameter and monitor value for BD series amplifier unit. User also can save and load setting using parameter 4 bank, allowing easy change between setting. Okay, for this sensor, the spec or minimum specification is CPU IBM PC compatible computer with 1 GHz plus processor. So for the operation, normally Windows 98, NT, XP, Vista 7, 8 and 10. So the minimum requirement for the memory is 2 GB and hard disk is 1 GB of available hard disk space. And the resolution is a VGA. Okay, the minimum requirement if VGA. Okay, resolution 1280 times 800 or higher. And then others is RS232C serial port, 9 pin and USB port. Okay, for this software got a ribbon menu. Okay, normally ribbon menu you can do as connect settings, live data, live graph, waveform graph and parameter. And then this one is a firmware version. You can see firmware version, model name. Okay, this one is status connected. If connected is a green color, connected to slave is also got green color. Okay, one is a master, one slave. Okay, for communicate with the software first, you need to have a converter, SCM. Our converter normally I use SCM-US48i, and then you communicate with this BDCRS. After that, you plug into the PC, use a USB port, and then you connect. It will pop up this setting lah, the connecting setting. Then choose the default is 115/200. Okay, click OK. After that, you can click connect, and then the connecting to the sensor. Okay, this one is an interface of our software. You can see if you already done the communicate with the sensor. Appear the click here parameter. You can do setting, all the setting inside this software, the parametric setting. No need to use a button. You just use a software to change the setting lah. Let's say you have a 8 unit here. You can edit all the setting by software. Okay. Okay, for the software got a parameter group 4. This one is a run function, and parameter group 1, parameter group 2, parameter group 3, and then operation mode lah. Okay, also have a bank, parameter bank. Okay, for if you choose a view to the view the display, we show the display, output display, and then the current PV and RV, and then high and low peak, also the status display. Also you can view in the graph. You can see the graph from the software. Okay, graph control window, you have a waveform status window and graph display. So for y-axis, okay, parameter setting, and then you can check the live data monitoring, so live graph monitoring and waveform graph monitoring lah. Okay, lastly, we go to the application. So normally our BD series used in to measure the product thickness. Product thickness. Okay, this one example of the product to measure the thickness. And also for this one also thickness application. Okay, and then to detect the level difference, this one also level different. Just want to detect a level difference. This one for sheet inspection for automotive industry, and sheet inspection for credit card inspection, and also for medicine to detect the capsule, the thickness, if got double or one piece. If double, meaning it's not okay lah. Okay, this one for level location inspection. So for automotive, displacement sensor can be used to measure the evenness of the automotive parts, such as automobile wheels. Okay, you can see the sport rim there. Try to check the evenness of the sport rim. So this one also automotive part manufacturing. So displacement sensor can be used to measure a level difference of various automotive parts. Okay, you can do level different measurement. And this one also for engine block manufacturing. So display sensor can use to be used to measure the height bonding dispense on the engine blocks. Okay, this one also engine block manufacturing line. So used in the robot to robot type extension cable can be used with a displacement sensor to detect the moving tray in the manufacturing line without worry of breaking because they use a robot type extension cable, so can use with the robot the moving object moving. Okay, thank you for the from now is the theoretical is okay. So now I will share some video. I will share some video of BD series. Wait, I check the file first. Please hold on. I need to check for the file. Okay, before we share the video, I will show you the live view of our BD series. Sorry because I cannot check for the file. So first I do demo first for the software. Okay, can you see my video? Can see the video? If you can see, you can just type OK in the chat box. Okay, now is how do I do installation for our BD? So this one is BD 100 lah, BD-100. You can see the power indicator is turned on. Okay, the far and near is in the ideal ID distance. So this one is a laser beam. Okay, and then this flight core that I installed to make sure the distance is 30 mm. And this one is an amplifier unit, and this one is a communication unit. To communicate with PC, we use this cable. I use this communication SCM48i. Okay, from here you can see the value lah. This one is a process value and this one is a real value. So okay, after that I will share the software. I will open the software and show to you. Okay, one more time. We share the software. Okay, now I open the software. Okay, this one is a add displacement software. Okay, first when you communicate, you need to check the setting, communication setting. Okay, you click the connection setting. So this one is automatic detect the COM port 12 virtual port VCPO, and then the baud rate is 11520. This one is a default value. You can click scan. Yeah, this one is a scan start. Okay, now it's detect the communication module as a unit number 1 and stop. After that you can click OK. Okay, after you click OK, click connect. Okay, now you can enter the parameter of BD. Now you can see the BD CRS unit address number 1, and then master is BD-A1. Okay, from here in parameter 4 you can do the setting for the direction. You can display can do a display sleep, lock mode, output, and then also run function. Okay, you can edit the parameter. This one parameter 1 and parameter 2 and parameter 3. All the parameter you can enter here by the software, and also you can see the live data. You can see the live data, and then also the live graph. Okay, live graph and the waveform also. Okay, and go back to the parameter. Let's say here you apply the run zero composition, just click run. Okay, after that you go to live data. You can see the zero. This one is a PV, becomes zero. So the real distance is a plus 0.4 mm real distance. This one is after we apply zero, it will become zero. Let's say I insert the name card. What happen if I insert name card? You can see the name card is around 0.8. 0.8. I move a little bit, maybe the evenness of the object is around maximum 1.5 mm. Okay, 1.5. Okay, I move the object, and then you can see the graph here. Okay, let's say no object detect is a 0, got object 1.4. Okay, 1.3, 1.2. Okay, no object, 0 back to 0. Got object detection. Okay, okay, no object, 0. Got object. Okay, no name card, 0 back. Got name card. Okay, so you can see the graph. Okay, I move on and off, on and off. You can see the reading for the graph. Also, you can start the log. Okay, you can start log. I will start log the process value. This one is a manual log. From this, you can do a analysis of your object. Maybe you need some sample for do a report. You can do this function. Can use this function to apply in your system. Okay, on off, on off, on off. You can see the PV 0 and got reading there. Okay, 0.5, 0, 0.5, 0, 0.5, 0. Okay. Okay, for the software part is already done. So maybe I try to open back the video that I have prepared. Okay, first I share my screen first. Okay, share screen. Okay, we go to the video.
Hello, I'm James Lee, one of Global Sales Manager in Autonics Corporation.
Everyone can see the video. If can see, just type OK. Can see and can hear the voice is clear. Can type OK. If cannot, I need to do some setting. Hello everyone. Okay, thank you. Okay, I will continue.
Today, I want to show you a laser displacement sensor we call PD series. A technological advancement has been providing us with much development in factory automation. So now we know how to get the signal when the target object passes through a specific area by using proximity sensor, photoelectric sensor, or other sensors. Then, how to measure the distance between the object and the sensors? If you wonder about it, keep watching this video. Laser displacement sensor is to measure the distance of target object by detecting the amount of displacement when its position is changed. By using displacement sensor, you can measure thickness, width, level difference, disparity, curve, and evenness of target object. As you can see here, displacement sensor can accurately measure the change of the height and width of the objects. It can be used at automobile industry, semiconductor industry, and other various industries. Autonics PD series is composed by head and amplifier separately. So it has some of the advantages such as simple installation, easy maintenance, convenient operation, and real-time monitoring by the amplifier. BD series has up to 1 micrometer resolution and can detect stable displacement regardless of color or materials. Furthermore, IP67 grade will guarantee for safe use in various environments. As you can see this, 4 I/O pins and 1 analog pin provide some input and output setting so that the user can easily set the parameters PV, SV, RV, and bank. BD series communication converter, BD-CRS, is based on Modbus protocol and provides RS-230C and RS-485 communication. One converter is able to synchronize with up to 8 sensors. In particular, we provide a dedicated PC software called @displacement for free. The software provides an intuitive interface and user-friendly design. By using @displacement, you can change parameters, check the real-time deviation values, and save the log data, which will be very useful for managing data, training purpose, or mass production lines. We hope that you can experience a high performance and reasonable investment cost for your project with our laser displacement sensor BD series. As Industry 4.0 revolution is coming into our life, Autonics Corporation is always thinking how to our life make easy and convenient. And we continue to research new products to be a leader of factory automation field. This BD series is just one of those products, and so many products are coming. So we ask for your continuous interest on it. Thank you for watching this video, and do not hesitate to contact us, since we are always here to help you. Thank you.
Okay, I think this. So I think this is the end of my presentation. So, Miss Lia can take over.
Uh, Thank you. Okay, thank you, Mr. Shaidan, for Q&A session. Okay, if anyone just write your question in the chat box. Any question from our